On a bitter morning in December 1963, inside Plant 8 of the Studebaker Industrial Complex in South Bend, Indiana, federal marshals and liquidators walked across a quiet assembly floor. Steam pipes groaned in the freezing air. The sharp smell of sulfur, cutting fluid, and damp sand hung heavy over miles of silent conveyors. These men came to secure a steel vault located behind the drop forge shop. Inside lay 3 leather-bound logbooks and master blueprints for a heavy military wagon chassis dating back to the Civil War. Beside those documents sat an 80-pound master drop forging die, hand-cut from solid crucible steel in 1862, and stamped with the eagle of a Union Army inspector. For over a century, that single block of forged steel set the metallurgical benchmark for every wagon axle, artillery limber, and truck chassis Studebaker produced. Liquidators ordered a scrap crew to torch the vault doors and cast the die into an electric arc furnace. But when the furnace operator dropped the steel block into the glowing bath, an electrical surge shorted the primary transformer coils, cracking the furnace wall and bringing the scrap line to a dead stop. The die survived untouched. Accountants were dismantling the old company, but its foundational iron refused to yield. You are watching Rivet and Rebar, where we dig into the industrial giants and mechanical sagas that quietly built our modern world. If forgotten industrial history, classic vehicle engineering, and precision manufacturing inspire you, take a moment to hit the like button and subscribe to support long-form mechanical stories. Your ongoing support helps us bring these forgotten mechanical legends and historical industrial triumphs back to life. Long before South Bend grew into a roaring citadel of iron foundries, heavy machine tools, and steam hammers, northern Indiana was a vast wilderness of wet clay, dense hardwood timber, and endless prairie mud. Transporting pig iron, grain, or timber to frontier towns required heavy horse-drawn vehicles. These wagons needed extreme structural strength. Yet in the early 1850s, most farm wagons were hand-built by local country wheelwrights using green, unseasoned wood and soft iron fittings forged over open hearths. These crude vehicles routinely fractured their soft wooden axles, threw their iron tires off the rims, and collapsed under heavy loads on rutted mud tracks. The saga of American vehicle manufacturing changed forever when 5 brothers of Pennsylvania Dutch heritage united their mechanical talents in South Bend. Their father, John Clement Studebaker, had built custom-covered wagons in Gettysburg, passing down an unyielding reverence for honest metal craftsmanship to his sons. In 1852, 2 of the brothers, Clement and Henry Studebaker, established a humble blacksmith shop with $68 in starting capital, a single hearth, and 2 hand-cast iron anvils. They operated under a strict shop floor rule. Metal must be worked white-hot, timber must be completely cured, and no work bearing their mark would ever leave the forge with a hidden structural defect. Shortly after opening their shop, their 19-year-old brother, John Moeller Studebaker, made a bold financial gamble. Joining the 1853 California gold rush, he traveled 5 long months across the plains, not to pan for gold in mountain streams, but to exploit the frantic demand for durable mining tools. Working in Hangtown, California, for a master smith, John spent 5 years hand-forging heavy wooden wheelbarrows, selling them to miners for $5 each. He returned to Indiana in 1858 carrying $8,000 in pure gold coins sewn into a leather money belt. That gold transformed a simple forge into a factory powerhouse. John bought out Henry's share to run manufacturing, while brothers Peter and Jacob joined to build a nationwide sales network. The 5 Studebaker brothers formed a rare industrial team, master smiths paired with business strategists who understood factory scale and quality. They held the line right from the start. Picture running a carriage works in the mid-19th century. The main mechanical bottleneck in vehicle manufacturing was not a shortage of skilled wheelwrights, but a persistent engineering crisis involving timber physics and wheel geometry. Wooden wagon wheels must endure relentless, multi-axis forces coming from every direction. Vertical weight crushes the outer rim, sideways sway twist spokes, and road bumps deliver heavy blows to the axle spindle. If the timber used for the spokes or hub holds even 5% excess moisture, natural drying causes the wood to shrink over time. When the wood shrinks, the iron tire wrapped around the outer rim loosens, the spokes wobble violently in their hub slots, and the wheel undergoes sudden radial collapse under load. Most wagon builders masked this flaw by forcing hot iron hoops over green wood. They told farmers to park their wagons in river creeks during dry summer months so the wood would swell back up. The Studebakers rejected this cheap compromise as an engineering disgrace. They constructed the largest natural timber seasoning yards in North America, covering dozens of acres stacked high with millions of board feet of prime white oak, hickory, and black locust. Every single piece of wood was air-dried under covered timber sheds for 3 to 5 full years, until its moisture content stabilized completely. To shape this cured timber into precision components, Studebaker built custom steam-driven hub-boring lathes, double-end spoke turning machines, and vertical mortising lathe set on heavy hand-scraped cast iron beds. These specialized tools machined spoke tenons and hub slots to tolerances finer than 0.03 of an inch. That is thinner than a human hair, and 1/30th the thickness of a sheet of paper. Every spoke end was hand-shaved, dipped in boiling linseed oil, and driven into mortised hardwood hubs using steam-powered presses. Next came the critical hot tire shrinking process. Heavy wrought iron bars were forge-welded into continuous circular tires, heated in gas furnace rings to 800 degrees Fahrenheit until the metal expanded, and dropped over the wooden wheel assembly. Custom hydraulic setting jigs submerged the glowing red wheel into a cold water quenching pit. As the cooling iron contracted with thousands of pounds of compressive force, it locked the spokes, hub, and rim into an indestructible structural disc. Seasoned iron swallows heavy vibration. Studebaker disrupted the market by introducing drop-forged axles fitted with case-hardened steel thimbles, precision hub boxes, Timken bearings, and spiral grease channels cut to spread heavy grease across spindle surfaces. Furthermore, they pioneered complete vertical integration across every manufacturing tier. They acquired tens of thousands of acres of hardwood forests, erected dedicated pig iron foundries, operated in-house varnish works, and built their own steel spring mills. By controlling raw materials from forest floor to forge fire, they eliminated third-party markups and standardized quality control across every assembly stage. They published transparent pricing catalogs sent directly to rural counties across America. Every sale came accompanied by a written guarantee promising free replacement for any component failure under normal farm usage. A Studebaker wagon never broke down. Quality was their armor. When the Civil War erupted in April 1861, the United States was plunged into a grueling war of industrial logistics. Moving armies required massive amounts of supplies. Cannon shells, gunpowder, medical gear, and rations had to travel over hundreds of miles of destroyed dirt roads behind marching troops. The Union Army issued an urgent call for thousands of military supply wagons, ambulances, and gun limbers. Studebaker responded by converting their South Bend factory into a high-speed military arsenal. Forge fires burned 24 hours a day. Steam-driven drop hammers echoed across the St. Joseph River as smiths forged axle clips, singletrees, and brake ratchets from tough wrought iron. When Union supply trains moved through the deep, muddy swamps of Virginia and Tennessee, competing wagons shattered their wooden axles and threw their iron tires. Studebaker wagons held their alignment, carrying 6,000-pound loads through mortar fire without structural failure. General William Tecumseh Sherman specifically requested Studebaker transport for his long marching campaigns, knowing their wheel hubs would never bind under heavy load. By the end of the war, the brothers delivered over 5,000 heavy wagons and ambulances to the Union war effort. Disaster struck in 1874 when a catastrophic fire swept through the South Bend plant, destroying the timber yards and main brick workshops. The Studebaker brothers rebuilt immediately, constructing fireproof brick facilities powered by centralized coreless steam engines and connected by private industrial rail tracks. By the close of the 19th century, the South Bend works covered over 100 acres, employing thousands of workers and turning out a new wagon every several minutes. As the 20th century dawned, the company navigated the transition to horseless carriages, producing early electric vehicles in 1902 and gasoline automobiles by 1904. During World War I, they supplied tens of thousands of transport wagons and ambulance bodies to Allied forces. When World War II broke out, Studebaker halted civilian car production entirely to build heavy machinery for military victory. Their foundries and machine shops produced over 197,000 U.S. 6x6 heavy military trucks for Allied logistics, over 14,000 M29 Weasel-tracked vehicles, and more than 46,000 Wright Cyclone radial aircraft engines for B-17 bombers. They held the line. Why were liquidators so desperate on that cold December morning in 1963 to destroy those leather-bound logbooks and that 1862 master axle die? The answer lay at the heart of a secret internal audit conducted by Studebaker's engineering department in 1958. During the late 1950s, as financial troubles mounted, corporate consultants hired from New York investment firms demanded to know why Studebaker's warranty service costs were so surprisingly low compared to Detroit's Big Three, yet their manufacturing costs stayed higher. The engineering team pulled original forging dies, metallurgical test records, and production logs going back to the Civil War. What they discovered was a profound mechanical truth that horrified modern corporate executives. The master axle die of 1862 was not merely a historical relic. It was the structural baseline for Studebaker's entire design philosophy. When Clement and John Studebaker engineered forgings, they built in safety margins of 300 to 400% over working stress. Castings were poured with thick wall sections of dense gray iron. Drop-forged steering knuckles, axle beams, and crankshafts were forged from alloy steel and machined on heavy beds that held alignment across decades of hard use. The 1958 audit revealed that Studebaker vehicles manufactured in the 1920s, 1930s, and 1940s routinely outlasted 2 or 3 engines without structural frame failure. Farm wagons built in 1880 were still hauling timber on Midwest farms 80 years later without requiring replacement hubs. Think about what that meant in a post-war economy driven by planned obsolescence. Detroit automakers shortened component lifespans, using thin sheet metal, pot metal gears, and stamped frame parts designed to fail within 5 years. Studebaker was building machines carrying a generosity of material that bordered on excess. Their cars and trucks were engineered so durable that they literally killed their own replacement market. The logbooks prove that Studebaker was bankrupt not because their product was poor, but because their iron refused to break. Accountants wanted those records destroyed to hide the fact that unyielding quality had been branded as a corporate failure. After decades of independent success, the downfall of America's oldest vehicle empire was accelerated by a ruthless corporate squeeze. In the early 1950s, Ford Motor Company and General Motors engaged in an unprecedented market share price war. They flooded dealerships with tens of thousands of excess automobiles, slashing retail prices to levels that left zero profit margin for independent manufacturers. Studebaker, operating with higher labor costs and smaller production volumes, could not match Detroit's predatory pricing. In a desperate bid for survival, Studebaker merged with Packard in 1954, forming the Studebaker-Packard Corporation. But the merger was flawed from its inception. Packard's executive leadership had concealed the true extent of their financial decay, presenting misleading sales projections to Studebaker's board. The expected capital infusion never materialized. Leadership fell into the hands of corporate managers and financial manipulators who had no background on the factory floor. They viewed the heavy iron foundries of South Bend not as the proud soul of American craftsmanship, but as expensive real estate liabilities. Cost-cutting measures were implemented with cold aggression. Metallurgical specs were downgraded. Skilled machinists were replaced by temporary line workers, and routine maintenance on historic machine tools was deferred. The legendary Studebaker Starliner and Avanti, designed by Raymond Loewy, stood as triumphs of performance engineering, but they were manufactured on squeezed assembly lines plagued by quality control issues caused by rushed production schedules. Instead of modernizing South Bend factory tooling, executive management diverted money into buying non-automotive companies to strip assets and shield profits from taxes. Quality was compromised. The true craftsmen lost control to the accountants. The final blow landed on December 9, 1963, when the board announced the immediate closure of the historic South Bend assembly plants, firing over 7,000 workers right before Christmas. Production was briefly shifted to a smaller plant in Hamilton, Ontario. But on March 17, 1966, the last Studebaker automobile rolled off the Canadian line, closing a 114-year saga of American vehicle manufacturing. The company died, but the iron did not. While the corporate entity called Studebaker collapsed under financial asset stripping, physical iron operates under natural laws that Wall Street accountants cannot destroy. Today, more than 60 years after the gates of Plant 8 were chained shut, the heavy physical evidence of Studebaker's engineering generosity endures across the globe. Walk into old job shops in Indiana, Ohio, or Pennsylvania, and you will find century-old Studebaker drop forge bases and heavy cast iron drill presses still bolted tight to concrete floors. Upgraded with modern digital readouts and electric motors, these massive frames continue cutting alloy steel to tolerances of a 10,000th of an inch. Their dense gray iron castings, seasoned by decades of thermal cycling, swallow spindle vibration better than modern fabricated steel weldments. In agricultural valleys across the American West, wooden-wheeled Studebaker farm wagons built in the 1890s still sit in barn bays, their oak spokes tight inside their iron tires, and their hand-forged iron brake shoes ready to hold a heavy load. Tens of thousands of Studebaker US-6 military trucks, abandoned in the Siberian tundra and South American mountain passes after World War II, still start when cranked by hand, their drop-forged crankshafts turning smoothly through thick gear oil. They outlasted the executives who tried to scrap them. They outlasted the banks that foreclosed on their factories. The company died. The iron lives on. Thank you for joining us today for this episode of Rivet and Rebar. If forgotten industrial history, classic vehicle engineering, and mechanical sagas inspire you, take a moment to hit the like button and subscribe to the channel right now. Be sure to click the video on your screen right now to explore another legendary saga of iron, steel, and American industrial ambition.